Ladies and gentlemen, please welcome Richard Climenhage, a commercial director at ANYbotics, who will present the first tech demo of the day.
Hey everyone, I'm Richard Climenhage, and I'm here with Andrea Tempreri, and we're from a robotics company called ANYbotics, and which was founded in 2016 out of Zurich, Switzerland. And with about 200 or plus employees, our robots are deployed globally. I also want to thank the first two sessions are up here for not contradicting anything that I'm about to tell you. Let's kick this off with a video, which has some really cool sound if we had sound. Gets a little drier. So what we're showing here is the antibiotics animal moving through. There we go. So, can you feel it? Based on everything that we've heard so far, we truly are on a robotics evolution that's actually going to lead to this revolution that's happening. Again, I was supported by all of the other robotics examples that were given from the back in the 80s and even before that. I think we first saw them in Popular Mechanics, if anyone remembers those magazines. The deployment of the robots, the robotic arms in factory floors. So they're now just commonplace, right? Any factory, any of the gig factories that have been produced, all have these robotic arms for the assembly, and also paint shops, etc. And then later on we've moved to robotics in warehousing, where the robots are. Well, it started with the robots actually bringing the merchandise up to the people that then had to pick them, to the robots actually now being able to pick from the shelves and building the baskets that are about to be delivered. And now what we see in this autonomous industry as we move forward are free-moving, fully autonomous robots that are walking through manufacturing plants, refineries, oil platforms, substations, and collecting consistent, trendable data. And it really is about the data, and so we can't lose that fact. The shortage of workers in industry is already being felt, and it's forecasted to be like an over 2 million worker shortage over the next 6 years. And those jobs are going to go literally unfilled. Additionally, plant downtime due to undetected issues is a $270 billion problem, and that's per year. And so using robots to collect multiple types of data as they're moving through the plant can, and again, it's the fact that it's consistent data that can be trended on. This can then lead to proactive maintenance. We can see the issues that are happening and plan for this, the potential challenges that we have ahead. Planned downtime is an accepted cost of doing business in plants, whereas unplanned, after a failure may happen, raises red flags and really never seems to happen at a good time. And then lastly, the human error. So unfortunately, we're the #1 cause of accidents in these environments that we're actually currently operating in. And what I'm told, you know, as I'm out and talking to various people, various potential customers, is the combination of this unplanned downtime, a failure, then with a technician having to come out and having people breathing over their neck is leading to even more challenges and issues and accidents. So robots are truly a better way to collect better data. Putting a positive spin on the previous slide, having robots collecting accurate, trendable data 24/7 can actually result in increased revenue. Our customers are reducing costs by having predictive, planned maintenance programs. They're able to have a robot go into environments that workers should no longer be going or are no longer willing to go out to. And additionally, by deploying sensors like a gas detector, we can sense the gases in various environments that then can lead to a more safe workplace environment and the environment overall. We believe that ANYbotics Animal is the most advanced industrial inspection solution. It's a fully integrated solution offering full mobility, and it becomes the perfect partner for the workers to work alongside the various workers. You know, some may say that it's man's or woman's best friend. Okay, you're a tough crowd. Operating fully autonomously, the robot can simultaneously, as it's moving through, collect data using the fully integrated payloads that you see up there. It looks like the head on the robot. So from the visual camera to the infrared camera to the bright light that we have on there that can get turned on where you're hitting various inspection points. So if you're operating in the dark, to the hypersonic microphone, so if you're listening to issues like motor issues or bearing issues, et cetera, all of these things are happening in plants right now. And all of this data is usually very inaccurately being collected by humans. And they might be out there with their IR camera and they're like doing a drive-by, and then they're able to check that box. And that's not data that you can trend on. So what we're seeing plants do is that they have all of this data, and maybe it's like months worth of data, and then even when they do have an issue or a breakdown, they can now go back here and go, okay, what did it look like leading up to that? And now they can take that and make that, or turn that into predictable maintenance. And so it makes it that much more useful, and that's where the true value is coming in. And then the LiDAR, as you see when the robot comes up, or at the back here for mapping out its environment, and any other kinds of sensors that we want to put on here. There's ANYbotics has a gas sniffer that it can actually sniff for, like toxic gases, or listen for actual leaks. So robotics and AI is not only the theme of this conference, but bringing them together, kind of like you had mentioned already, is what's making, or what gives the animal extreme agility and this full autonomy. And so I'm glad that I was very careful with what I said here. With so many humanoids being developed right now, I'm often asked, okay, so why are you still developing a four-legged dog? And it's at this point in time, as you can see from the video, it's just much more stable and reliable in the environments that our customers are deploying or want to deploy them to. And so it was something that we heard on the panel earlier with respect to, it's all about safety. And we just need to be very careful if you see it's going up the stairs, et cetera, and it's working alongside other workers, human workers. It can't be, falling down the stairs and then potentially, injuring that particular, those workers. AI is nothing new to ANYbotics. We've been using it for years now in actual development of the robot and the testing of the robots. And I'm glad there's so much said about simulations, and this is kind of the aha moment, or the kind of the mind-blowing moment, is that the simulations these days are so powerful that you can actually test any code that's been produced for the robot hundreds of thousands of times and actually change your coding and see how that affects, all in simulation, before it's even ever downloaded onto the robot and put on a stairs, for example, in real time. ANYbotics affiliation with ETH. So for those of you that aren't familiar, it's a major Zurich university, so think Carnegie Mellon or Stanford. I'm sorry if I didn't announce your robotics university, but as well as these other partners that we have listed here are helping to drive robotics and the resulting applications. What's next? As you see and hear, and as actually you heard earlier, it's going to be the robot's ability to interact with its environment. So whether that's going over an obstacle, under an obstacle, around it, and opening doors, and et cetera. And then that's going to lead, and someone said this exact same point. For example, as it's walking through the factory floor, what it's doing right now, it will not just capture the data and alert on it, it will try to fix it. So what I love here, if you already saw the dishwasher, and here, we'll just give it a second. I love that it uses its foot to collect that, because I know we've done that many a time. So thanks for listening. And now I want to introduce the ANYbotics animal, George. So what you'll see on one of these screens is what George is actually seeing as it comes across the stage. It's on a fully autonomous mission right now, and so that's what's unique about the animal, is that from day one it was developed to work autonomously. The only time it really needs to truly be driven is during setup. So earlier Andrea came up here, he used the LiDAR to map out this whole environment. That environment actually lives in the memory of the robot. It's not using GPS. It doesn't have to be connected to GPS. And as it makes its way to stairs, it just switches the mode and continues on. But what you saw here is it came up, it stopped, it turned its head, it actually captured IR. I don't have the IR on there right now. And it'll make its way over here, it'll capture another image, and then make its way back to what could be its docking station, where it would power back up. And what I'll reiterate is the value in these is the fact that it's the ability to carry these payloads that are going to then be able to capture data, consistent data, that then can be used by our customers. All right. Thank you much. Appreciate it.